Welcome to Summarize Science. We all use powerful AI models like ChatGPT, but we also know they can make things up or get things wrong. This is a huge problem, especially when we need them for important tasks. So, how can we know when to trust an AI's output? Take this math problem, for example. An AI tried to solve it in 5 steps, but as you can see, it made a mistake on the 3rd step, which made the rest of the answer wrong. Wouldn't it be great to have a score for each step that tells us how likely it is to be incorrect? Previous methods tried to do this using a statistical tool called p-values. The problem is, you have to set your error tolerance, say 10%, before you see the scores. If you change your mind after seeing them, the mathematical guarantees are completely invalidated, a problem known as p-hacking. This is where the new research comes in. The authors propose using e-scores, a new type of score that measures incorrectness. Notice here how the correct steps have very low e-scores, close to 0, while the incorrect steps have very high e-scores. The brilliant part is that e-scores allow for what's called a post-hoc guarantee. This means you can look at all the scores first and then decide what your tolerance for error is. This flexibility is a game changer for how users can interact with these systems. So how does it work in simple terms? The system is given a set of calibration data, which are basically examples of correct and incorrect AI responses. It then compares a new AI response to these examples to calculate its e-score. To prove it works, the researchers tested it on 2 key tasks. First, they checked the mathematical reasoning of various AI models, just like in the first example. Second, they tested if AI responses satisfied important properties, like being helpful and honest. The results are shown in these graphs. The orange dots, representing their e-scores, almost always stay below the guaranteed safety line of 1. In contrast, the blue dots for the old p-score method often fly way above it, showing that its guarantees fail in practice. The precision recall curves on the right also show that the e-scores perform just as well as, and sometimes better than, the p-scores at identifying correct answers, but with the added benefit of that flexible guarantee. So, let's recap the important points. Researchers have developed a new method using e-scores to assess the correctness of AI-generated content. Unlike previous methods, these e-scores provide robust guarantees even when users choose their tolerance level after seeing the scores. This was shown to be effective for both mathematical factuality and satisfying property constraints. What could this mean for the future? It's a huge step toward more reliable and trustworthy AI. Imagine AI tools that can flag their own potential errors in real time, allowing you to use them for high-stakes tasks with much greater confidence.